using Carcater and cons. Should be expert at those by now. Let's see, then there were several examples like that for you to review and go over. Also higher order functions, so, and that's all the categories, that is functions that input other functions, functions that output functions, as well as lambda functions. I don't think lambda functions made their way onto one of the quizzes, but they could appear on the final exam, so you should probably review those. And another thing is tail recursion. We didn't get a chance to do much with tail recursion. We went through one example, and there weren't any requirements in your scheme homework to write something in a tail recursive manner. So I think that what you should understand what it means for a function to be a tail recursive and why that is an advantage. I'm kind of limited in what I could reasonably ask you to do in terms of writing a function that's tail recursive. It would have to be something very, very similar to the one here. Okay, then next, everybody's favorite topic, the pumping lemma. You should understand what the purpose of the pumping lemma is, what it allows us to do, and you should know what the pigeonhole principle is and how that's related to pumping lemma and how that's related to regular and non-regular languages. And then you should be able to apply the pumping lemma in a reasonably simple case, similar to what you had to do on the quiz, where I give you a language and you show me using the steps of the pumping lemma that it is not regular by stating a particular string and then showing that it can't be pumped by explaining what are the limitations on the pumping zone and finding a particular number I of the number of times that pumping occurs and the string that it results in that isn't in the language. That's what we spent a lot of time practicing. That's what you had to do on the quiz, and that could be said again on final. So there are some examples in the notes. One thing about these notes, there's a section at the end that says additional discussion. I won't test you on any of that. I know, just having seen some of your quizzes, that there are a few of you that preferred the method that was described in here. And if you fall into that category and I ask you to do something with the pumping lemma and you do it using the methodology shown in the additional discussion, that's fine, you can do that. But you're not required to, and I won't ask you anything about that section. All right, then we did push-down automata. The section on push-down automata was relevant to context-free languages, and so you should be comfortable with creating push-down automata. Let's see here, as well as the instantaneous description for showing a particular derivation. And one thing that did not make its way onto the quiz was converting a context-free grammar to a push-down automata using this stock three-state system for a solution. There were a few people that did use this methodology on the quiz, where I asked for a push-down automata, and there were a few people that actually instead wrote a context-free grammar and then used this and converted it, and that's how they came up with a push-down automata. And if they did that, there were a couple people that did that correctly and got credit for it. But I didn't explicitly ask you to do this before on the quiz, but I very well might ask you to do that on the final, so you probably want to review that section. Okay, we've been spending a lot of time lately in the logic paradigm and prologue. So just as in the scheme, I might ask you to write some prologue code. So you should be comfortable with the sort of pattern matching that we've been doing in the parameters, and setting up rules and facts, being able to tell what a query will return. One of the things that I didn't ask you on the quiz was to trace a query, show all the bindings step by step as Prolog does its search, such as was shown in this section of your notes, and we walked through it on the board. We did the walkthrough showing all the bindings step by step, and then at the end showed the same thing as a tree. That's something you probably should review. It didn't make its way in the quiz, but it's very likely to be on the final in some form. You should be, I know a lot of you struggled with lists on the final quiz. Hopefully the practice we did right after that helped a little bit. I would certainly encourage practicing some more, because I want you to do well on the list processing part of that homework. Of the final exam. So besides the examples we did in class, there were the other examples in the notes. One thing that was not on the quiz was generate a test, even though it was on your homework, so it could be on the final exam. It's one of the most important programming techniques in logic programming, so that very well could be on the final exam. There's plenty of examples of those. After much gnashing of teeth and agonizing, I've decided I'm not going to put cut and fail on the final exam this time. If we just did, in some semesters I've had assignment problems that required you to use cut and fail, but this time I didn't. So I won't have a cut and fail question on the final exam. Then we've studied Turing machines, and here too, I should be able to ask you to do a Turing machine. We probably had a little less practice with Turing machines than with the other automata, so any ones that I ask you to do will be on the simple end, something very similar to one of the ones we did in class. Not any, certainly no more complicated, more on the easier side. But you should definitely review them. If you review them and understand them, and can say cover the solution and work it out for yourself, you'll probably be prepared. But you should also understand the instantaneous description for showing the computation done, a particular computation done by a Turing machine, and hopefully not getting confused with the other instantaneous description notation for PDAs. There are examples in the notes of various Turing machines doing various things. You should understand the Church-Turing thesis and its importance in computer science, what it means and what its importance is in computer science. And then the last section, parameter passing. So if the way the class went this morning is any indication, this section is divided into three parts. We're going to go through this today. This section is divided into three parts: pass by value, pass by reference, pass by value result, and pass by name. And in the previous section, which had pretty much exactly the same amount of time that we have left, we got through the first three. We got through pass by value, pass by reference, and pass by value result. And we did not do pass by name. So I expect it will be the same thing for us. So so you don't need to know the material from pass by name on it. But the first three sections could be on. So we'll cover that now. So before we do that, are there any questions about the final exam? Is there anything you're wondering if it's going to be on there? Yes?
Just to re-clarify, you said pseudocode, we don't need to do it in a particular language for coding?
If I were to ask you to write a parser, then I don't, then you could write it in pseudocode.
Okay.
If I ask you to write something in Scheme, then I want it in Scheme. If it's in Prolog, then I want it in Prolog, not pseudocode. Yeah, Scheme and Prolog, I could actually ask you to write real code. For the parser, no, that pseudocode would be fine. Other questions?
I guess for Scheme, are there any built-in functions that we may or may not use? Is that applicable?
I think the same rules as for the homework. Right. For instance, I could ask you to write a function in Scheme that computes the length of a list. I mean, that's a reasonable level of difficulty problem to do on the test. But if you just say, well, I call list length, well, that kind of defeats the purpose of the question. So, mathematical functions would be fine. Other than that, just the functions that were listed in the notes. Car, cons, cadir, null, math functions. Quote. Yeah, other questions? Okay, well, let's get on to this topic. Parameter passing.